Hi everyone, welcome to today's Python session. In this class, we are going to learn one of the fundamental libraries of data science, that is NumPy. NumPy stands for Numerical Python. It helps us work with the large amount of numerical data in a fast and effective way. You will see NumPy in machine learning, artificial intelligence, image processing, statistics, and everywhere. So today I will clearly explain every term: arrays, indexing, slicing, arithmetic, random numbers, and linear algebra with definitions, examples, output, and real world uses. Let's begin. What is NumPy? NumPy is a Python library that is used for processing large numerical data. It provides an object called ndarray, which stands for n-dimensional array. It is support first operation because NumPy is written internally in C. For example, first we have to import the NumPy module. Import NumPy as np, as we have to using the alias. In this case, np.array 123, that is create a NumPy array from a Python list. This array is stored in continuous memory, that is making it first for math. NumPy arrays allow vectorized operations, that meaning we don't use loop. In real time, we have to using in machine learning data like pixel values, sensor reading, audio features. All are stored as NumPy array for training models. Next, we have to discussing NT array or n-dimensional array. An ND array is a multi-dimensional array. It can be one-dimensional vector, two-dimensional matrix, three-dimensional image tensor, and 4D, 5D we have to using a deep learning or databases. In this example, this is a two-dimensional array with 2 rows and 3 columns. In this case, b dot shape tell us the dimensional. That is real world application we have to using a image stored as a 3-dimensional array, that is height, width, color, channels. Next we have to discussing array indexing. That is indexing means to selecting a specific elements from the array. There are so many different types of indexing: single element indexing, slicing, Boolean indexing, fancy indexing. First we have to discussing about the single element indexing. In given example, the index 2 means to pick up the third element, because indexing start at 0. The output become 30. That means we have to using a data analysis, we often inspect a single value of a data set. Next, focusing on the slicing. Slicing means to select a range of value using start to stop. In this example, start at index 1, end at index 4, but 4 is excluded. This is used for extracting subset of the data. That is used for to select the mini batches in the machine learning. For example, the 0 to 99 numbers. Next one is the 2D indexing. In this example, the syntax of the 2D indexing, the array open square bracket row comma column. Row 1 comma column 2. That means second row and third column. that is mainly used for the matrices. Next one is the Boolean indexing, that is to select the element based on a condition. In given example, we have to certain condition can be obtained, that condition become d greater than 5, that create a Boolean mask. The NumPy returns only value where the condition is true. That means this type of indexing we have to using a filtering value. For example, selecting patients with fever greater than 38 degrees Celsius, we have to cap the that corresponding value, that corresponding patient details can be obtained. Next we have to then another indexing that cannot be mentioned, that is the fancy indexing, that is selecting multiple elements using a list of the indices. That can be used mainly the stored the indexed list. That means to select the specific rows from a data set, that using a stored index list. That we have to discussing in the array arithmetic. That means NumPy support the element wise mathematical operation, that is called the vectorization. In given example, the mainly the two terms x and y, we have to first we have to perform the addition operation, then we have to perform the multiplication operation, then next one is the scalar operation. That means in this case there is no need for the loop. NumPy applies the operation to each element. This make a numerical computing extremely fast. In first example, the x and y can be added. The output become the 579. That means 1 and 4 will be added, 2 and 5 will be added, 3 and 6 will be added. The multiplication case, in this case, x multiplied by 5. Then the output become 1 multiplied by 4, 2 multiplied by 5, 3 multiplied by 6. That becomes 4, 10, 18. Then scalar operation, the x is multiplied by 10. That means the x row can be multiplied by 10. The 1 multiplied by 10, 2 multiplied by 10, 3 multiplied by 10. The output become 10, 20, 30. Next we have to discussing about the transpose of a matrix. The transpose means swap rows and columns. In given example, it is a 2 by 3 matrix that becomes 2 by 3 by 2 matrix. That is very important to the matrix multiplication. It is used to linear algebra and gradient calculations or neural networks. In given example, 1, 2, 3 is the first element, 4, 5, 6 is the another elements. That can be rearranged in the 2 by 3 and 3 by 2 format. Next we have to discussing random numbers or pseudorandom numbers. That is NumPy generate random numbers using algorithms called pseudorandom numbers generator. In given example, we have to using a seed. That is seed ensures the same result in every time. This is necessary for reproducible experiments. Next one is linear algebra in NumPy. The NumPy has a special module NumPy.len algorithm. That means linear algebra. For the linear algebra function, the linear algebra function commonly mainly perform the different types of operations: matrix multiplication, determinant, inverse, and the eigenvector and eigenvalues. First we have to discussing about the matrix multiplication. In given example, the matrix multiplication is row or columns, row by columns. This is the basis of the neural network computation. In this example, we have to using the 1, 2, 3, 4, the first element, and the second element is 5, 6, 7, 8. We have to using the dot operator. The output become 19, 12, and 43, 50. That is the matrix multiplication rule will be applied row by column, row multiplied by column. Then next we have to focusing on the determinant. The determinant tell us whether the matrix is invertible. That means determinant 0 means no inverse exists. Next one is inverse. The inverse matrix is when multiplied with A and gives the identity, matrix will be produced. Next one is the eigenvalues or eigenvectors. That means eigenvalues to represent how the matrices stretches the spaces, and eigenvectors show the direction of the structures. In given example, we have to using the values and vectors, we have performing the keywords of the eigenvalues and the eigenvectors. This is mainly used for the PCA, that means the principal component analysis, to reduce the dimensionality. Then these terms are mainly focusing on the NumPy analysis. That's all for today class. I hope the concept were clear and example they help you understand how to apply them real world situation. Thank you for watching.